Hey everyone, so excited to be here today. My name's Tracy. You can follow me on Twitter at LadyLeet or on LinkedIn at Tracy S. Lee. We're going to be talking about the 7 stages of AI adoption for developers today, joined by my
Yeah.
co-speaker. Is it called a co-speaker? What do you call what do you call us? Co-speakers?
Yeah,
Technical term.
that's right.
Yeah. So, anyways, we're gonna be talking about this incredible journey from fear to flow. My name's Tracy. Again, I already said this. I do a lot of things with community, etc. Lately, helping a lot of people at this.labs, which is a software consultancy, help adopt AI developer tooling. So, it's been a fun adventure.
And I'm Rob Ocel, the VP of Innovation at This.Labs, also the host of a couple of our podcasts, like the Modern Web Podcast and the Leadership Exchange. So you should check those out as well.
At this dot, we've never been so excited to play with and learn new technology in our entire careers. Maybe you're one of those people who are still on the fence, and we love those folks. We love to talk to the skeptics because when we convince you all that AI is really worth the hype, it's the best feeling in the world. But our goal here in this presentation is really to share what makes us so excited and optimistic about the use of AI in software engineering and why we think it's really good for our industry. There's so much hype out there, and we've been hearing it for God, probably 2 years now, right? But our interest was really piqued when we heard about how Airbnb was able to convert nearly 3,500 test files from Enzyme to React testing library in less than 6 weeks. That task was originally scheduled for 1.5 years. So while these results aren't typical, people using AI have found that a majority of our work can actually be drastically accelerated through sophisticated use of AI agents.
And this is a little bit hard to see on the screen, but we were really interested with tweets like this that show someone, out in the sun, enjoying some time in nature, maybe soaking up some rays. But meanwhile, they're getting serious work done. So this is someone from the AMP Code core team who's running parallel agents to develop AMP Code. So you maybe already have used software written from the agents in this picture right here. And so, like, what a powerful thing that we can be so productive, even outside of our office, just because we have these AI agents working for us.
Yeah, and if you believe in energy, Rob, I definitely believe, like, if your code was written on the back porch during sunset while you were vibe coding, is it just like better energy code in the world or something like that, which means that your product is going to be more successful? I'd like to think so. But before we explain more about our vision for autonomous agentic coding, we sort of need to talk about this whole like human in the loop, right? This is kind of the big elephant in the room. Um, you know, Everybody's afraid about like what AI might do to our industry and our jobs. And while we can't predict the future, we definitely want to share some of the reasons why we're cautiously optimistic, and why we feel like it's gonna be okay. So the first quote is a quote by Scott Galloway, from his recent podcast, The Pivot. It says that, there's been a real kind of gag from a lot of employees who are very suspicious about AI at the enterprise. They're asking, okay, are you asking me to cooperate in my own execution here? And we've heard this and seen this firsthand from our clients. There's definitely tangible pushback that you hear and you see and you feel from engineers, that their managers are pushing AI only to reduce headcount. But again, we remain pretty optimistic about things.
One of the reasons why we're so optimistic about this is actually because we've seen in other industries that have gone to full automation that they're actually sort of reverting back to bringing humans back into the loop. So, you might know this, that manufacturing has been using fully like robot run manufacturing lines for a while. Now, you may not know this, but we're actually in the fourth industrial revolution right now, at least as the industry tracks it. And we're knocking on the door right now of the fifth industrial revolution. And the idea there is personalization, because what automation has allowed factories to do is produce the same thing over and over again very efficiently and very cheaply. But what people are craving now is the ability to customize what they want. They want those personal touches. And it turns out that fully automated factories aren't very good at that. And so we're on the verge of the fifth industrial revolution, which is bringing humans back into the loop, working alongside machines in order to produce the kind of results that consumers today are expecting and demanding. And it's these types of forces that we think are going to be true in the software engineering world as well. We don't think that will end up fully automated.
And I think one of the best ways to combat any sort of negative effects we might be afraid of experiencing with AI on our careers is to learn how to use AI well now. I love this tweet from David Kramer. It says, "Show me your number one spender and I'll hire them." And this again shows how valued AI skill sets are now at all levels of seniority in tons of engineering orgs. We've also seen a lot of sort of, I don't know, discourse, I would say, on the internet about companies that we know, like GitHub, right? There's a lot of advancements, and the advancements in AI have actually led to them hiring more juniors because a lot of people, right, within organizations, if you're in one, a lot of executives feel like, oh, these people won't change. So if I bring in new blood, new energy, they're more malleable, they're more interested in potentially using AI, right? So companies are really valuing that sort of fresh perspective from junior developers who aren't as resistant to using AI. And companies are definitely, even in this thought, we changed our hiring process to want engineers to sort of be AI native first.
And I think the other reason why we're still pretty excited about the effects of AI on the industry is that what we found is that a lot of software right now actually isn't being written because it's just too expensive. There isn't enough time, there isn't enough money, there isn't enough resources in order to write that code. And so what we've actually found and heard from people that are really using AI effectively is that they are now writing the types of features and the lines of code and the products that they wished they had time to write but never did until now. And so what we expect to see is that until we've exhausted a lot of that capacity and that desire to write code, we'll find that the more AI we use, it's not that we need fewer coders, it's that we actually need even more because we're producing more code as we can write that code faster. So we think that this is going to be a pretty exciting time actually for the release of a lot of code aided by AI.
All vibe coded on your back porch during a sunset, right? And I think another thing, right, that we're facing in this industry is, a lot of us haven't started, right? So if you haven't started learning anything about AI yet, that's okay. Danny Thompson, who works at This Dot, he says we're in the great forgiveness period right now. That just means so many of us are just starting to learn. There's no reason to be self-conscious. The best thing to do is just start sharing with your peers what's happening, learning alongside them. So how do we start?
So we've developed at This Dot what we call kind of the AI couch to 5K. We believe that these are the 7 stages to becoming an effective AI engineer. First and foremost, it's important to understand that what we're talking about here is your ability to use AI as an engineer to build whatever product it is that you're working on now. This isn't necessarily to build new AI tools or to build new tools that expose AI features to clients. This is just you using AI effectively as an engineer. The first step is going to be understanding the why. Understanding, again, what we're doing, what this is all about, getting excited so that you have the motivation to make it through the rest of this journey. Then learning the most important lingo. Then we're going to explore agentic coding tools now that we know all that lingo and we know what we're actually working with. After we've explored agentic coding tools, then we're going to get into prompt engineering and understanding how to use those agentic coding tools even more effectively. Once we understand prompt engineering, then we're going to be able to customize agent behaviors by using prompts to change the ways our agents respond in certain situations or when editing certain files. Then, now that we know how to change how agents behave, we're going to augment them even further by using tools and MCPs to expand their capabilities and allow them to assist us in all sorts of ways we could not have imagined until recently. And once we've built that level of sophistication in our usage of agents, then we need to maximize our agent autonomy and allow coding agents to be capable of producing code in production in our systems autonomously, so by themselves, for longer and longer periods of time, which is where we truly unlock the productivity promises of AI.
I think one of the things to realize, and I definitely felt this way, I felt this way in the blockchain Bitcoin era as well, right? Like, what the heck do you start learning? And there's so much to learn. There's so many terms, there's so many different libraries, so many different agents, so many models, so many companies. It is so overwhelming, but don't feel like it's just you, it's everybody, right? So, the key to being the most productive as quickly as possible is just to realize that not all ideas in the world of AI are equally important when starting your AI journey. We're really here today to talk to you about like how do you be productive as a developer with developer tooling, right? So focus on real definitions and really develop a good mental model of core ideas such as models, agents, tools, MCP, context windows, all these other topics like vectors, tokens, RAG, fine tuning. That's information that you don't need to know right now to get productive immediately. And funny enough, a year and a half ago, I think it was about a year and a half ago when I really started digging into this. The vectors, tokens, RAG, and fine tuning was all I was focused on, right? But if you focus again on the models, agents, tools, and MCP context, that type of stuff, that is really what is going to be able to enable you, right? Also, there is an amazing YouTube channel called AI Engineer. It's a great conference. So watch all of those videos there, and you'll really learn a lot about what you should actually be paying attention to right now.
And it's important to note again that if you are building features on top of AI or exposing AI to your customers through your product, then some of these things that are marked as unimportant will be very important for you to understand. This is simply for you being someone who is trying to use AI to build whatever it is you're building now. So this is for your productivity specifically. All right. The next then is to explore agentic coding tools. I mean, one of the number one questions we get asked all the time is what is the best tool to use right now? Like, what should I be using? I use Cursor. Should I be using Roo Code? Everybody's talking about Claude Code. Should I be using that instead? There are a lot of agentic coding tools, and there's more coming out every single day. Many of these are great. I will say a lot of people at this.labs enjoy Roo Code, but we have a number of people using all sorts of different tools. So there is no one best. But whatever you choose to use, there's a few things for you to consider of what might work best for you and your team. So for example, is it going to be a plugin or a standalone IDE? A standalone IDE being something like Cursor, where you download the program and that becomes the new tool that you do all of your coding in. Whereas other ones might be plugins. Roo Code is a plugin that works in VS Code as well as Cursor and other IDEs, and that allows you to bring these agentic coding capabilities into whatever IDE it is that you use. Or maybe you want to use one of the CLI options that then doesn't even need an IDE at all. Use the tool that works best for the way that you and your team are looking to edit code. Next is fixed cost or metered token billing. So what we're saying here, and honestly, there aren't that many fixed cost ones anymore, but there are a few that are still out there. And these are the types of ones that'll say something like, hey, for $20 a month, you can do a certain amount of tool calls or things of that nature, certain calls to the model. Versus other ones which just have you bring your own keys to things like Anthropic or OpenAI that you pay for, and then they just pass all of the tokens through your keys, and you just pay for them as you use them. We've found that using the token-based billing gives us the best results because the types of agents that are using that model tend not to do the types of things that save money and help them make margins because they're not worried about keeping you under an arbitrary subscription limit. So I would say if you're using it for work, look towards token-based billing ones that are fully metered. If you're working on your own on the side at home on your own cost, maybe some of the subscriptions are going to be fine for you, but you will eventually run into limits with those. Next is MCP support. Even since the first time we gave this presentation, Tracy, this is now almost a universal thing, but you do want to make sure that whatever agent that you use is capable of adding MCPs because those will become very relevant to extending your use of these agents and adding functionality and tools to the types of workflows that you'll build out every day. Next is customizable agent prompts and modes. You want to make sure that you have the ability to change the way that the agent behaves. Now, this could be things like rules, agents, modes, things like this. So you want to be able to make sure that you understand, how can I change the behavior of this tool to allow it to have different forms? Maybe I want to have a code review version, which is specifically engineered and changed and adapted to be better at code reviews. Maybe I want one that helps me when I'm creating architectural designs. Roo Code has one, for example, that's really good at orchestration and breaking up a complicated task into many sub-agents. You want to make sure that you have that flexibility in whatever tool that you use. You need to make sure that you have autonomous support. This either comes through workflows or orchestration or some sort of pattern, so that you can make sure that you can start to do some of the autonomous flows we're going to be walking through. And you, of course, want to make sure that whatever agent you're using is multi-model. Avoid the ones that are tied specifically to a certain type of model. You want to be able to explore and experience new models as they come out. Again, new versions of models are coming out all the time. You want to use the one that's best for the task at hand. So as I said, there's no clear best tool. Find the one that works best for you, and stick with it. I think early on, people switch around tools too much when they really just need to be learning how best to use any agent, and all those skills that you learn are transferable to whichever one you ultimately go to.
We'll be back to the episode in a second, but first, I'd like to acknowledge the team behind the channel, This.Labs. We're seeing 3x to 5x productivity improvements with our teams and clients using tools like Cursor, Claude Code, and GitHub Copilot. We help teams adopt these technologies and get max value out of them through strategic partnerships, trainings, and other software engineering services. Check us out at ai.this.co. Thanks, now back to the video.
I think prompt engineering is also another thing that is people, there's books on it. People want to study it, and it was definitely all the rage when ChatGPT first launched, right? It's like, oh, what is a good prompt? And this is an important skill, but it's not sort of like the end all be all, right? You don't need to become the perfect prompter. There's QR codes on the screen, so you can actually scan it and just see all the different guides that exist for prompt engineering. And I think one thing that people don't understand, which hopefully we can help you understand here, is you don't have to be the perfect prompter, because agents are actually really good at turning your crappy prompt into better prompts. So if you ask AI, hey, tell AI what you want and how you want the AI to respond, it's going to show you how to actually prompt and what those best practices are to get actually what you want. Or if you went through something and it took you 10 prompts to get what you actually needed, you can actually go back and say, hey, it took me 10 steps to actually get me what I needed. What can I do next time to better improve my prompt? So I think it's more important to start utilizing the skill than to sort of try to think about how you need to perfect prompt engineering, right? Also, it's important to know that hallucinations, meaning AI just completely messing up your request, can't be eliminated through prompt engineering alone, right? There's other tools that can help reduce these sort of hallucinations, but don't over-index on this.
The next step, remember, was to customize agent behaviors. We do this primarily through custom modes and rules. Custom modes is ways that we can say, hey, when you're operating in this mode, the agent should have access to certain sets of tools. It should behave in a certain way, and it should respond with a certain cadence. So it's like a special system prompt that also gets put in with your prompt to the underlying model, and it also constrains and gives access to certain tools. That's really important, because the more tools and the more MCPs you have access to, that all gets added to the context, and context is very valuable. You don't want to confuse models by giving it a lot of irrelevant context. And so one of the ways we can control that context and make sure that we're getting the best responses we can every single time in the right situations is to make sure we have modes that are perfectly tailored to the types of situations we put our agents into. Rules as well are ways that we can change the behavior of the agent with respect to certain types of files or locations. So it's important to realize that customizations can be universal. In other words, I always want my agents and my editors to behave in this way. They can be mode specific. So it can say when you're writing code, I want you to do these things, but when you're writing design documents, I want you to do these things. And when you're doing code reviews, I want you to do these different sets of things. It could be project specific, right? So on this product, it's a front end project built in this framework. So we care about these types of coding standards. But this other one is a back end product in this totally different language. So it's going to have these types of rules, right? So you can have custom rules based on the project that you're in. Or they can be context specific. You can say, hey, inside of this project, when you open a TypeScript file, these are the important things I want you to do. But when you open up a Markdown file, these things are important, or anything else along those lines. So it's important to realize that you can really customize the behavior of your agents in many different ways. And it's important to think what the best way is going to be for you and to be most effective with your team in using these tools going forward. Next is tools and MCPs. So the important thing to realize is that tools add capabilities to your agents and your models, right? You tell the models what exists, when to use them, and how to use them, right? There's nothing magical about these LLMs that knows how to make a Google call. But what we do is we say, hey, there exists an internet out there and you can search it if you want to. So if you think searching the internet is good for you, I want you to tell me to search the internet and what to search, and then I'll tell you what I found. Tools are very similar. We give the LLMs a list of things that they are allowed to do. They invoke those tools, and then the agents return the results and feed that back into the model, and ultimately that's what you'll see. Tools have been in agents forever, right? We start to take this for granted now that the earliest versions of some of these LLMs didn't have any ability to, for example, search the web. So you might remember that it would be like, well, it's very good at knowing things, but only things that have happened more than 2 years ago. That's no longer the problem, right? That's because agents have started having more sophisticated tooling. Some tools are built in, but then for the ones that aren't, we have MCPs. So MCPs, or Model Context Protocol, is a way for us to add new capabilities to our agents. It defines a set of additional tools and capabilities that we can make our agent aware of that it can then execute. And the power of them is that we don't have to wait for our favorite agent to add support for our own tool chain. So if you use GitLab instead of GitHub, or you use Jira instead of GitHub Issues, or whatever that is, you can now install an MCP server that exposes your very specific tooling chain to your model so that you can drive power and use them more effectively. This has really unlocked tremendous potential in AI productivity chains. Now, be careful though. It might be tempting to go into your agent and enable every single tool. I think recently there was something like 160 plus tools added publicly to Claude, so you could just click to turn them all on. The more tools that you add, all of that gets added to the context. And the odds that the model will choose to use a tool that maybe isn't right for the job goes up tremendously. So you want to beware. Don't add too many unnecessary tools. Just like with your prompts and your context windows, include only that which is most relevant, and you can control that, again, as we said before, with custom modes and with rules.
Yes. And autonomy. Autonomy is one of my favorite things to sort of talk about in this journey. And this is the last stage of the couch to 5K that we talked about, right? So how do you improve your agent autonomy through orchestration and workflow? So let's talk a little bit about what that means when we talk about autonomy. This article is actually really good on sort of categorizing different levels of agent autonomy, right? So many of us are operating right now at low autonomy. We're tab completing with Cursor or Copilot. Maybe we're asking ChatGPT some questions. The next step is to start asking agents like Cursor or Klein to perform complicated coding tasks with large prompts. And so then those models are going to sort of make multiple edits to multiple files in our repository all at once. The future, which is like what we showed earlier, is where agents are left to code for hours without human intervention, right? Again, imagine that sunset, that back deck, that life, lemonade, whatever you have in your hand. And sort of getting higher in autonomy is where you go from that 20 to 40% productivity gains to 100 to 300%, all of a sudden 1,000% productivity gains. And that's how this thought sees the future and near future, if you will, also of autonomous agentic coding.
And so that's where we've developed what we believe is the AI enhanced software development lifecycle that we're all going to be using here in the very near future. And it's also the cycle that we've begun using on several of our client projects as well. and we'll showcase here where humans really operate most effectively. And this is that humans will come in at the beginnings and ends of the software development lifecycle. So we're there first and foremost in the beginning, developing requirements alongside agents, coming up with documentation, deciding what it is we're going to build. AIs will never build the next billion-dollar, trillion-dollar company. I had to upscale. I forgot now, NVIDIA's $4 trillion. So we're talking trillions or gazillions at this point.
I'm going to go totally we need to save that clip. And then 10 years later, I'm going to replay that clip. I'm just going to email you that clip right now.
There we go. We'll keep editing it to add more zeros. But yeah, AI will never make the next unicorn company. And the reason for that is because at the end of the day, what makes humans amazing is we're the ones with the discernment. We understand and can make the important decisions on what we think is the need that will be met by our product and our company. So we come in and we make those difficult decisions on what we're going to build, how we're going to build it, and what that's going to do for our users. Once we've set all that up, we begin a long agentic flow which will produce implementation plans, which is very much like an architectural document based on all the requirements and documentation we've put together. Then it'll take that architecture and pass it off to a design agent who will decompose it into a set of tasks. Then each of the coding agents will kind of go to the Kanban board and keep grabbing tasks and implementing them. Other coding agents will review the work of those agents, much like we review the code of each other right now. They'll also run standards and tests and linting tools and all types of things like that to make sure that there is quality amongst the code that's being written. And then this process of sort of building, reviewing, and then fixing will continue until the code is finally approved by agents. Then when you come back after a long period of allowing these agents to run as a human, you will then not have a stack of pull requests to review, but instead you'll have a stack of features that are ready to launch that you can then review and accept them, revise them, reject them in the same way that you might decide whether or not features should go into your application. There's really sophisticated ways that this can be managed in the code, in the repository as well. And so we think that this is a really potent way. The more that humans get involved in that agentic flow, the slower the overall process will be and the smaller the gains you're going to see from adopting AI. So we think it's really important to find ways to allow the AI to be autonomous for longer and longer periods of time. This is a process that is feasible now. Like I said, it is being done on major projects, major things that you might already be using now, things like Claude Code, things like AMP Code, as well as mainstream products as well. We're using it on some projects. It might be too sophisticated for many teams and for many organizations, but this is where we believe the industry will be going here in the near term. So I wanted to showcase what this might actually look like. And one of the best ways to do this is with sort of a brief demo. So we looked around for some ideas on, what it is we could build. And we found out that AccuWeather actually has a set of public APIs. And so we said, okay, that's great. This sounds like it would be a really exciting demo to give. So here's all this documentation. Here's an example of what the documentation would look like for a particular API. Well, this is a lot of data, and it's also on the web. It's very difficult for LLMs to just go out to the web and have this information. They may not have this in their training set, or they might, or it might be out of date. It's hard to say. So I don't want to rely on what's in the training set. I want to make sure that that my code is documenting exactly the APIs we want to use and how we're going to use them. So an example of how I did that is this. I told the agent to read the documentation. Well, first of all, it should be noted that Markdown file is just a set of links I had to all the pages we said before. So I grabbed a few of the pages from that AccuWeather page and I said, put it into a document. And I said, go read all of these links. And I want you to give each link to a different agent. That agent's goal is to document all the information that's contained within. So I went out and had each agent go out to each one of those pages, document what was there, all the important information, all the arguments, the parameters, the error codes, exactly how to use them, things of that nature so that we could augment that. And I said, document all those things in Markdown files and put them in a documentation folder. Now, it took that and it broke it down into a lot of subtasks, each of which was given to a different agent. The important thing to note here is why did we use different agents for all of this? And the reason for that is the sort of the context length. You can see it sort of in the center of your screen there. The context window is the maximum amount of information that the model can process with any given request, right? And so in this case, we're using Claude. We get up to a 200K context window. And two things start to happen when you start using up more of your context window. First of all, you're spending more money because the cost of each request is going to be determined by the amount of tokens that it uses, and that's ultimately your context window. So the more data you're sending with every request, the more processing the model has to do, the more you're paying. The second is your hallucinations will start to go up. If I had given all of the pieces of documentation to one single agent to document, it would have been good for a little while, but what would have started to happen is as it was starting to summarize the 9th, 10th, 11th pages, we would have started seeing information from the second, third, and fourth leak into the later ones. And this is just simply because, again, these LLMs are not humans. They don't think like humans. They're models and they're sophisticated and they're probabilistic. So if you put information in the context window that is not relevant to the task at hand, the odds that it will do something unexpected and undesired with that information goes up. So we control our context windows very carefully by breaking up the task into separate independent pieces and giving each to a different agent. And this is an example of the type of agent that it spawned. You can see that the agent that I triggered actually wrote this prompt for me and gave it to one of the subagents. So this is the type of documentation that it produced. You can see over on the left-hand side, there's all the files with the markdown that it created. And over on the right, you can see the types of information that it included. It included the links to the actual endpoints that were called, in the parameters, the return codes, all of that information that's going to be relevant both for me as well as the agent going forward. I should note as well, if you didn't see it, I mentioned that it should write this documentation for the purposes of consumption by agents. That's an interesting little optimization on my part because you might have noticed that models love to write really flowery prose for the benefit of humans. And we don't want that necessarily because, again, that's unnecessary wording. We want it to be quite efficient and terse. So I told it ahead of time that I want the documentation to be written in a format that is best suited for agents to consume. So now that I've documented all this information that was on the web about AccuWeather APIs, I need to decide what I'm going to do. I decided I want this website to be written in Next.js. So I said, hey, I want to use the best practices for a Next.js application found on this webpage, as well as the documentation in that docs folder that I already created. And I want you to create for me a comprehensive implementation plan for a Next.js website that uses version 15.3.3 and allows users to enter a city in the search bar and figure out the weather in many different formats, right? And I told it to also, again, make that plan for agentic consumption. And it went off and created a plan that looks like this. It's in many different phases. You can see in each phase, I have a scope, a set of deliverables, the files that will be created or edited, what the success criteria is, and any dependencies. This is later going to allow the agents that actually do the work to understand the order that they can complete the work in and what actually needs to be done. I said, okay, great. Well, now we have an implementation plan. Now, though, there might be mistakes. So I want you to review the implementation plan that this other agent created, and I want you to figure out if there's any issues with it, and if there are, fix those issues. So it did, and it discovered some things. Some of them are kind of funny and ignorable. For example, it now thinks that instead of it taking 39 to 57 days, it'll take 58 to 63 days. We can ignore this, and this isn't actually a hallucination. It's just sort of somewhat irrelevant piece of information. But the important thing here is that it actually caught some big issues. It found 8 major dependency version issues between the different libraries that the original plan said to use. Now, if you've ever used an LLM to vibe code something, you know that getting stuck in dependency hell is a very real problem that sometimes stymies a lot of people before they even get into the fun of building something. And just by having another agent check the work of a first agent, I dramatically reduced the types of hallucinations that would really cause me problems if I had set this off on its autonomous path by itself. It would have spent maybe hours trying to resolve the issues that's caused by using these incompatible library versions, and by running one additional prompt to check my work, I've dramatically improved the quality of the product. All right. So now I said, using this implementation plan that's been corrected and the documentation that we've put in the docs folder as needed, break this plan down into a set of tasks and systematically implement them using subagents. So basically what I've told it to do is make its own Kanban board. I said, create a new markdown file and task to track the progress against the plan. This helps a lot with recoverability. What happens if your agents fail for some reason, or you have to interrupt them, or the whole process gets interrupted? You want the agents to keep track of what they're doing at every step of the process so that if you ever need to pick it back up, you know what's completed and what isn't and where it can start again. So if it discovers that there are new tasks that need to be done, either because a code review exposes them or because it discovers an additional complexity in the implementation part, it should add those things to the list as well so that they can be prioritized and worked on. And that's basically it. I added some extra settings to make it faster to run on my local machine that aren't as important to this flow. So here's an example of the type of task that it broke down. Now remember, it's going to go through that big plan that it created, and it's going to give each one of those subtasks to different agents one by one and get the information from them. So it wrote a task here, a call for an agent for me that took one of the tasks off the list and gave it to it, told it exactly what it was to do and how it wanted it to respond and what the documentation was and things of that nature. Here's an example of what the Kanban board looked like in the middle of running it. You can see some of the tasks are completed and some of them are not completed. And this is how it was keeping track of what was left to do. And here's an example of what it actually built. So I should say really quickly, I'll go back 1 second, that this was actually the last prompt that I wrote in this process before the final conclusion. And it ran for several hours building this, correcting issues, adding features. It added authentication. It added all sorts of security. It added rate limiting, all sorts of things that are overkill for a demo, but show how sophisticated the software can be that something like this can make. So I've made no additional requests after this. This was all I did. I let it run for several hours, and the version it created was this. So it's a pretty nice looking Next.js website, but a pretty basic functionality. So we're going to go into this demo, and you're going to see that we're going to be able to type now the city that we want. It's going to give us some autocomplete on the location that we're looking for. And now that we've done that, it's going to load the weather. And so there you go. We've got a pretty powerful example of not vibe coding. This is not vibe coding. This is an organized, autonomous, agentic code flow that you can use now on your projects to reduce hallucinations and really build complex softwares using cutting edge technologies at very high reliability. So we're really excited about what this can do for our teams, and we're really excited what this could do for your teams.
I'm just looking at that Celsius versus Fahrenheit. I'm like, okay, is there like a toggle there that we can change that? But yeah, it is really exciting to see what is possible these days. Again, at this time, we're so excited about this. We've been talking to so many different companies and helping so many different companies at all different levels. And so whether that's, hey, we can help you sort of do an AI strategic rollout in 2 days, or we can, we talked about the fact that we embed AI first engineers into organizations in your sprints who are hands-on keyboard to help people like skeptics be convinced that like, hey, this is possible within your code base. So if you need embedded AI engineers who are champions, be happy to do that. There's just so much excitement happening. We're doing a lot of events around this as well. Check out ai.this.co to check out more. We have an upcoming workshop too, so definitely check those out on our ai.this.co page. And thanks everyone for listening, and we hope you are excited. We hope you're as excited as we are about AI these days.